All right, day 3, simplifying radicals. We're going to rationalize denominators. So you need to understand, what does that mean? And all it really means is you can never have an answer that has a radical sign in the bottom or in the denominator of a fraction. So we're going to have to get rid of those radical signs out of denominators. We're going to remember that the square root of a times the square root of a is a. So a square root times itself gets rid of the radical sign, which is going to be helpful because we're trying to get rid of the radical sign in the denominator. All right? Now, you want to continue to do all of the things that we've done in 5.6 first. And then if you still have a radical in the denominator, we will use this new rule or this new method to get rid of it. So number 1, the square root of 4 divided by 5. Okay, you cannot divide 4 by 5. So we would separate them to the square root of 4 over the square root of 5. Well, we know what the square root of 4 is, so that's 2 divided by the square root of 5. Now we're going to remember, you cannot mix numbers with radicals. So this is a 2 and this is a square root of 5, which is some decimal. The only way to get rid of the square root of 5 off the bottom is to multiply both the top and the bottom by the square root of 5. Now this is legal because root 5 divided by root 5 is the number 1. And so all we're really doing is multiplying by 1. Multiply the top and you get 2 root 5. And if you multiply the bottom, we know that root 5 times root 5 is simply 5. So we've gotten the radical off the denominator. Okay, next one. Root 6 divided by root 3. Now again, I said you want to make sure that you follow all the rules that you've done already before you do this method, because there might be easier ways to get rid of the radicals. Well, this is a radical divided by a radical, so we know that you can divide them, and that's simply root 2, because 6 divided by 3 is 2. Another way to think about it is if you put it back together under a single radical sign, we would know that that would be the square root of 2, because 6 is divided by 3, which is a little bit different than this first one because 4 and 5 you couldn't divide them. Here you can divide them. So you want to look for easier methods before you go to the harder method. Number 3, the square root of 5 divided by the square root of 3. You cannot divide 5 with 3, so that method won't work. So now we have to go to the harder method. How do you get rid of root 3? Multiply it by the square root of 3. So you multiply the top by the square root of 3, which is ultimately multiplying by 1. Multiply them. 5 times 3 is root 15. And root 3 times root 3 is 3. Now you can never mix radicals with numbers. Very common mistake is people will say, well, that's got to be root 5. Root 15 divided by 3, you get root 5. But you cannot mix radicals with numbers. That isn't legal. This is a decimal divided by 3. Okay? That's not root 5. So don't make that mistake. Number 4, the square root of 12 divided by 6. Well, 12 divided by 6 is 2. So we don't need to do any of this hard work. What happens if they give you coefficients in number 5? Well, again, do the things you already know how to do before you start adding new rules. We would already know that we could say 3 divided by 6 is 1/2. All right? And we know that root 8 is root 4 times root 2. So on the bottom I've got 2 root 3. On the top I've got 2 root 2 over 2 root 3. Well, I can cancel these 2's. So I've simplified the problem before I ever worried about there being a radical on the denominator. Now you can't divide a 2 with a 3, so now you have to multiply by the denominator. On the top you get root 6, and on the bottom you get 3. Again, don't make the mistake of thinking you can divide that. One's a radical, one's a number. So most students don't have too much trouble with this. Okay? If you have a radical in your answer on the denominator, you need to multiply by it, and then you need to multiply by it on the top too. They get a little bit harder when you make the denominator more complicated. Okay, so if you look at number 6 down here, the denominator now is 4 minus root 3. I'm going to go back up to this in a second. Now most kids are like, well, Miss Gonski, geez, just do what you just did, multiply by root 3 and root 3. So on the top you get 5 root 3, and on the bottom, well, we would need to distribute this. So we would get 4 root 3, and then here you would get, oh, those match, so you get 3. Well, did that work? Did that get the radical off the denominator? No, it just moved it from this spot over to this spot. So see, that method won't work for these problems. So we need a different method. Now why? Well, this problem has a complicated denominator, has a minus sign, or sometimes it'll have a plus sign in it. So we're going to use what's called the conjugate to get that out of the denominator now, instead of just multiplying by the root. So what's a conjugate? Well, if the number, or if the denominator is 5 plus 2b, then the conjugate would be 5 minus 2b. If it's 4 minus 3a, the conjugate would be 4 plus 3a. So what you're going to do is essentially create these no middles. So if it's 5 plus 2b and we multiply it by 5 minus 2b, that's a no middle. So all of our denominators are now going to be made into no middles. When we do our foiling, that should be faster. So I would recommend you put parentheses. So we notice this is complicated, so we know we need to use the conjugate. So the conjugate would be 4 plus root 3. And on the top, we also have to multiply by 4 plus root 3. Okay, things to think about. Down here, we've got a no middle. So it's a FOIL no middle. And on the top, we're going to distribute. Okay? On the top, you get 20 plus 5 root 3. Now remember, you can't add those together. They're not like terms, just like before. When you do this no middle, you're going to get 16 minus 3. Root 3 times root 3 is 3. 20 plus 5 root 3 all over 13. Final answer. Okay, we'll try another one. They don't really get any more complicated than that. Alright, so we got a radical on the denominator. We got to multiply by the conjugate. 4 minus root 2. So put parentheses because that'll help you remember how to do it. 4 minus root 2. Now remember, we're multiplying by this. This is really just the number 1. Okay, so that's legal to do. This time, however, it's still going to be a no middle because it's always going to be a no middle on the denominator. But the top, instead of distributing, we're going to need to FOIL. So the top is a little bit more complicated. Now you can do the top or the bottom first. I tend to start to do the bottom first because it's always easy with a no middle. 4 times 4 is 16, and root 2 times root 2 is minus 2. Alright, now we're going to have to FOIL the top, and it's just a regular old FOIL problem. So 5 times 4 is 20. 5 times negative root 2 is negative 5 root 2. 4 times negative root 7 is negative 4 root 7. And root 7 times root 2 would be plus root 14. So on the top, are there any like terms? No. Can you break down root 2? No. Root 7? No. Root 14? Well, it's 7 and 2, but that doesn't help us, so we can leave it as a 14. So the top cannot be changed. And the bottom becomes a 14. And that is your final answer. It's not very pretty, but it's your final answer. Common mistakes. People think they can cancel these 14s. No. First of all, this is a radical and this is a number, and you can never cancel with a radical and a number. Okay? Some people are like, well, can't you cancel the 20 and the 14? You can divide them both by 2. No, you need to remember there's 1, 2, 3, 4, 5 spots in this problem. If you can't cancel 2 in all of these spots, then you can't cancel it in any of the spots. So kind of need to remember that rule. All right, one more to practice. Put parentheses around it and multiply by root 2 minus root 3. Okay, again, the bottom is always no middle. And on the top here, we need to FOIL. I like to do the bottom first because it's easier. Root 2 times root 2 is 2. It's always a minus sign. Root 3 times root 3 is 3. On the top, root 2 times root 2, 2. Outside, root 2 times negative root 3 is negative root 6. Since they're both roots, you can multiply them. Inside, root 2 times negative root 3 is also root 6. And last would be plus, because it's negative times a negative. 3 times 3 is a 3. Add your like terms. We get 5 minus 2 root 6 all over negative 1. They will never leave a negative 1 in the denominator of a problem. So you need to be able to get that out of there. So our final answer would be negative 5 plus 2 root 6. Okay? We will practice some more on Tuesday after Christmas break.